All right, so it's time to do some more practice with some basic DT, VAT, do some kinematics practice, stuff like that. So I'm going to start with this here. Grab this. All right, so here you are in your car cruising along. Got a pretty sweet ride right there. Okay, I believe that's a Mustang right there. So there you are in your sweet ride, and you are cruising along. And let's say that you're sort of cruising along here. Let's give you a level. There you go. Let's say you are cruising along. Oh, let's make it a little bit thicker. There we go. You're cruising along at just 12 meters per second. Okay. Now you got a bit of a surprised look on your face because you're not really paying attention because you're probably texting or something while you're driving. And what happens is I come along, go zooming right past you. Okay. So I'm out here. All of a sudden I come from behind. I zoom right past you. And I'm faster than you are. And I'm coming along. Oops. Wrong tool. And I go blow right past you. And I'm moving along, and let's say I am going to be going 40 meters per second. All right, so I'm cooking at 40 meters per second, and I'm going to blow right past you. All right, and we are trying to get to the same place. Maybe over here there's a car show over here that we're both trying to get to. All right, so I'm going to whip right past you 40 meters per second. Now, to get to the car show, let's say the car show is, give or take, let's say it is 3.2 kilometers away. So it's 3.2 kilometers to get to the car show. You're going at 12. Again, you're probably texting. I'm whipping right past you at 40 meters per second. I'm going to get there first. So, of course, what do? You are going to step on the gas in order to try and get there at least at the same time, if not try and beat me there. All right? So, if you wanted to do that, what you want to do is you want to get there at the exact same time. What acceleration would you need to be able to do in order to actually do that? Okay, well, let's figure this out. Let's see if we can piece a few things together here. Now, first of all, my motion is easier because I'm just moving at 40 meters per second while you have to accelerate. So I'm just going to look at what I'm doing on my sweet ride first. So for me, I've just got constant motion, so that's really simple. I've got my speed is 40, and that's constant. I also know how far I'm going. I'm going the 3.2 kilometers. So I've got my speed, I've got my distance, I can easily find out the time. So the time it's going to take me to make it to, I don't call me car number one because I'm number one, would be the distance and the speed. And I got a nice constant speed, so that's a lot easier calculation. So it's got to change the kilometers into meters. Of course, that'd be 3,200 meters. I divide that by my 40 meters per second. And it's going to take me 80 seconds to get there. So you need to get there in 80 seconds. And you're not going to be doing that texting, traveling at 12 meters per second. So what you need to do is you need to step on it but good and go faster. So that's what you're going to do. But now that we have the 80 seconds, it's the same time for you in your car. You are also going to, you've got 80 seconds to catch up to me. The other thing is that's the same as the distance. You also need to go 3.2 kilometers or 3,200 meters. Those two things are the same. So we can use that information to figure out what you are going to be doing. Well, if you need to go 3,200 meters and 80 seconds, we can calculate your average speed. Now, it's not a constant speed like mine. It's going to be an average speed for you because you are accelerating. So for your yellow car, the average speed for the yellow car is going to be your distance and time. Of course, distances are the same. The V's are the same. Or not the V's, the T's are the same. So the average speed you will need to do is 40 meters per second. So your average speed needs to match my overall speed. Okay, so your average speed needs to be 40. So here we're going to draw my little V thing I usually do. you're starting at 12 meters per second. You don't know your top speed, but you know your average has to be 40 meters per second. So 40 is right in the middle. Well, it's not too hard to figure out what the top speed is going to be. You know, you're starting at 12. In order to get to 40, you're just going to have to add 28 to that. So that's an increase of 28, which means this would also have to be an increase of 28, which means your final speed over here is going to be 68 meters per second, which is probably around 250 kilometers an hour, which these cars could do relatively easily. All right, so now that we know that your little yellow car needs to go from 12 meters per second to 68 meters per second. So your change in V would have to be the difference between the two. So 68 take away the 12 gives me a change in V of 56 meters per second. Okay, so your change in V is going to have to be 56 meters per second. All right, well, now that we know that, I've got my change in V, I've got the time, it's the 80 seconds, I can find the acceleration. So the acceleration that you need would be your change in V divided by your change in T. So the change in V is 56 meters per second, and you've got 80 seconds to do it. So 56 divided by 80 gives us an acceleration of 0.70 meters per second squared. Okay, so you need to accelerate at 0.7 in order to get to the car show at the exact same time as me. All right, and of course, when we get to the car show, my car will beat your car. I'll get first place. You'll get maybe 8th place. Okay, all right, just the way it is. Okay, so there's another combination of DTV, VAT stuff put together. All right, so let's try a different question as well. Okay, so for this one, let's start with this. Here we are, we've got a little spaceship going on. So we've got a spaceship flying through space, and it's just sort of cruising along. And then, of course, run into trouble, runs into some bad guys. Okay, of course, the bad guys start shooting at him here. Pew, 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 pew. All right, so the bad guys are shooting at the good guy. So, of course, the good guys got to try and escape. So what the good guy is going to do is he's just flying along. He's flying along. He's going to whip around, and he's going to fly the opposite direction. And his plan is to hide behind an asteroid over here. Okay, so let's move that over a little bit. Okay, give ourselves a little more space. Here we go. All right, so he's flying along at a constant speed. Bad guys come into the picture. He whips around, zoom, and takes off this way, and his plan is to hide behind the asteroid over there. Okay, so let's look at some values here and piece a couple things together. All right, so let's say that the ship here, let's say the ship was going at, it's going to be pretty fast. Let's say it is going at 350 meters per second for, let's go with 18 seconds before it turns around. It's going to whip around this way. It's not going to, when it whips around, it's not going to, slow down, speed up. It's just going to whip around and just change direction. So it's still going 350 when it whips around. But then, since the bad guys are chasing him, going pew 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 with their lasers, he is going to, of course, speed up. And on the way back, on this way, he is going to accelerate. He's going to accelerate at 40 meters per second squared for, let's go with 16 seconds to then hide behind the asteroid. All right, so let's try that. Actually, whoops, wrong one. Yep, that's okay. So I'm not even going to give you an actual question or anything like that. We are just going to start by finding stuff, because that's a great way to often start questions like this. So there's basically two parts. There's the way there and the way back. So I am just going to start finding stuff for the two parts. So first of all, the ship was just going towards the right. So I'm just going to start out by finding some stuff on the way going to the right. Now I know it's going 350 for 18 seconds. That's just a constant speed. I've got speed, I've got time. I'm going to find the distance for the first part. That's relatively straightforward. So if I find out how far it went to the right before the bad guy showed up, using basic DTV, it went around 6,300 meters towards the right. And then, of course, what it did is it did a little U-turn type thing, and it took off the other way. Now, I know when it took off the other way, over here was still going 350 meters per second. But there's an acceleration for that part for 16 seconds. So I got acceleration and I've got time for the second part, so I'm going to use that. Acceleration and time give me my change in V. So I'm just going to find my change in V. So my change in V for the second part is going to be the acceleration during the second part multiplied by the time for the second part. So if I just do that 16 times 40, my change in V is 640 meters per second on the way back. So it whipped around, it was going 350, and then it went even faster by 640. So if I add that to the 350, it ends up going like 990 meters per second. Well, now that I have the initial speed for the second part and the final speed for the second part, I can find the average speed for the second part as well. I'll just get the average of the 350 and the 990, and we'll find out the average speed for the second part, which is around 670 meters per second. So right in the middle here, it's like 670. Okay, well, now that I have the average speed for the second part, I've got the time for the second part, I can find the distance for the second part. So my second distance would be, basic DTV. So I'll take my time of 16 seconds, and I will multiply that by the average speed of 670 I just found, and I can find out the second distance was just over 10,000 meters. Okay. All right, so I've got all these bits and pieces and stuff like that so far. All right, well, now that I've found that distance, it went 6,300 to the right, and then it came back to hide behind the asteroid around 10,000. Well, if I know that, let's see, I can find its displacement. So we started here, and the ship, here, we'll even use the ship. Let's see, the ship went 6,300 meters this way, whipped around, and went around 10 grand this way. So it actually ended up around 4,000 behind where it started from. So that would be my displacement. Okay, so it ended up over here. So that would be my displacement. So my delta D, or my displacement, would be the difference between the two. So if I just subtract them, I can find out that my little spaceship ended up around 4 grand, and it's negative because it's behind, so negative 420 meters. So it ended up 4,420 meters behind where it started from. All right, so that would be like it's from like here-ish to here, where it's supposed to be hiding behind the asteroid. All right. Well, now that I have the displacement, what could I find with displacement? Well, I've got the total displacement. I could find the average velocity. Okay, so I could find the average velocity for my spaceship. So the average velocity for my spaceship would be the delta D over delta T. Well, I just found my delta D. That's my negative 4420. And my time would be my total time put together. I got the 18 seconds, I got the 16 seconds, so that's 34 seconds all together. So if I take that 4420 and I just divide that by the 34, I get an average velocity of 130. And it will be negative because he's ending up behind where he started from. So it would be negative 130 meters per second. Okay, so that would be the average velocity. Well, is there anything else? Well, I could also find the average speed, which is actually usually easier than average velocity. The average speed for the entire thing would be like the total distance and total time. And the total distance would be the, let's see, he went 6,300 to the right, and then he went back 10,720 to the left. So the total distance traveled would be just over 17,000 meters. It's still divided by 34 seconds. That doesn't change, which gives us an average speed of around 500 meters per second. Okay, so there's the average speed. So there we go. So I did the entire question. I solved for absolutely, I didn't even start with an actual question. I just took the information and just started piecing things together, putting things together, and there really isn't anything else to really solve for in the situation. That's pretty much it. Average speed, average velocity is all done, got the acceleration, distances, times. There pretty much isn't anything else to solve for. So again, you don't actually need a question in order to actually start working on problems like this. Just start by finding stuff, and one thing can lead to another. Even when there is a question given, if I would given you at the very beginning, find the average speed, find the average velocity, it doesn't make any difference because you would probably start pretty much the exact same way and go through the exact same process. So often it's not about what you're looking for, it's about what you have and what can you find with what you're given, and it'll eventually probably lead to what you're actually looking for.